supply that is just being paid for your own native token to be staked with these validators, right? So we said, okay, how can we make this a bit more productive to the system?
Hey everyone, I'm Shane. I'm a research partner at Hack VC, and I'm joined today by Zon, who's the co-founder of Initia. So let's get started.
Howdy, I'm Zon. Okay, so I'm at Initia. Initia is a network for interwoven rollups. Am I supposed to be talking at you or the camera?
Both.
Okay, both. Okay, hello out there, but also hello. So Initia is a network for interwoven rollups. We holistically rebuilt how multi-chain networks should look, feel, and operate along the architecture, the product, and then the economic systems that tie them together. So before we dive into a bit more about what Initia is and how the architecture works, let's do a quick summary of how blockchains have evolved so far and what scaling has kind of looked like.
Yeah, sounds good.
So in general, I think there's been two camps. There is these monolithic chains. And this started with, obviously, Bitcoin, which is still live and great. New all-time highs. Woo! Okay. Oh. Okay, and then we had like Ethereum. And at the same time, we kind of had this other concept called Cosmos.
And so what's the main difference?
So Cosmos was this idea that instead of having one chain where all state is stored, you have this idea of app chains. So an app chain is a blockchain that is purposely built to solve one solution or application, or to give some sort of new property that isn't there on Ethereum. The reason you could do this is because you could spin up these Cosmos chains a lot easier than having Ethereum and all of the validators and stake agree to a certain update. So Cosmos started to evolve in what they called the Internet of Chains. So you had things like, Terra, and you had stuff like Osmosis and Neutron, and you had stuff like Noble, and this kind of evolved. And you have this thing in Cosmos with it, which is like native bridging. Allows for all sorts of message passing, but also token transfers. And that is called IBC. It stands for Inter-Blockchain Communication. So Cosmos kind of scaled by building more and more chains. How Ethereum decided to reach scale was this concept of rollups, right? So people started building rollups. It started with OP and Optimism. Then you had Arbitrum. And then you had this idea of the OP stack, which lets you build rollups very easily using Ethereum as a settlement layer and using OP as like the system by which you build an optimistic rollup. And so you had all of these optimistic rollups on top of Ethereum. And then, out in the distance, you also had stuff like Solana and Sui, trying to scale in different ways the monolithic blockchain idea. But with more and more rollups on the rise, because people wanted to customize different features of their chain, it's not just about scalability, right? Maybe you want to change the way that transactions are ordered, how they're processed, what type of gas token you use, what the virtual machine you're using on your chain is like. And so this is the flexibility that Cosmos SDK provided, right? It gives you full reign to change the way that a blockchain works. But there are problems with it. So what are some of the problems with Cosmos? Most notably, these are all layer ones, which means you have to run a validator set. You have to bootstrap your security, which usually means you have to inflate your token to pay for that security.
And a lot of infrastructure.
Yeah, basically just lots of effort, right? But rollups made it very easy to launch your chains. But what are the problems with rollups on Ethereum right now? essentially it is that, you can write it for me. It is, they are fragmented, right? There's no native system for communication or token transfers or bridging. They require you to use the EVM. So you have very limited choices when it comes to the virtual machine you use and what types of smart contracts you build on there. There's no way to get under the hood and change the way that transactions are ordered and processed. Mm-hmm. So basically, unflexible. No ordering. Right? And so basically, rollups on Ethereum were very easy to launch, but they don't provide you anything unique. You get the same copy-paste fork every single time you build one of those blockchains. Mm-hmm. But most of the time, to build a real, proper, great application, you need to customize and focus what's being built to provide a better user experience. Mm-hmm. You take something like DYDX. They are an entire chain. Another one is Hyperliquid. Hyperliquid is a chain that also uses the Cosmos SDK stack, mm-hmm. or at least Comet BFT. And they reorder the way that transactions come in to make better maker and taker relationships. That is not something that they would be able to do on Ethereum or another EVM layer 2.
Couldn't they do that if they control the sequencer? Or
if they've had sole ability to control the way the sequencing is done, yeah, they could probably do that. But it is very suspicious if they have manual ability to do it.
Yeah.
Right? There's no way to easily create programmatic rules for doing so.
Yeah.
But in the Cosmos SDK, there's already lots of different systems. There's this thing called Skip's protocol owned builder module. And what that lets you do is it creates different lanes for your mempool. So a mempool is like where all the transactions come and they sit when they're about to be processed by a block. So new transactions come in here, 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 right? And then they all go to the block. What mempool lanes let you do is create different customized ordering mechanisms for transactions that come in. So I could say, okay, Oracle updates, they come into this mempool lane, which means that they can appear at the top of a new block before these transactions here.
They have some sort of priority, basically.
Right, they have some sort of priority. Or I can say the ones that come into this one have free transactions. Or the ones that go into this lane are going to be ordered by a auction that's done, kind of like an MEV auction. So there's all this flexibility that is just built into the Cosmos SDK already. So we essentially said at Initia, how can we solve a lot of these problems by building a full solution, which means a layer 1 plus a layer 2 system that kind of combines the best of both worlds and creates a much more seamless experience for how the multi-chain should develop. Right? When you have kind of complete control over the architecture, the product, and the economics, you can create alignment over the way that the entire system evolves. And that means how different blockchains are communicating with each other, how value flows in the system, but also how the user experience is used across all these different blockchains. If we're under the belief that there will be thousands of blockchains in the future, we definitely need a UX flow that makes it seamless for everyone in the end. Mm-hmm. And so by having control over things like the product from day one, you already have the distribution to be able to change the way that users come in and use these new blockchains. And so let's hop into the architecture of Initia.
Perfect, yeah.
Okay, so we start off with the Initia layer 1. So the Initia layer 1 is a Cosmos SDK base chain, right? So here we have at the bottom, we have Comet BFT. Comet BFT is the rebranded name of Tendermint, which is the consensus layer that's used for every Cosmos-based blockchain. So, yep. Then we have the Cosmos SDK.
So this is how all the validators negotiate and decide how to
That's
agree
right.
upon a block.
Right.
Yeah.
Common BFT is the system that's used for all the validators to communicate with each other, decide on the ordering of transactions, and then ensure that everyone has the same state, and then produce the block. What's cool about using Comet BFT and Cosmos SDK is that there's this entire ecosystem of developers and blockchains that are contributing to this stack. So anytime
Hundreds of chains.
Exactly, hundreds of them. Anytime someone makes an improvement to the system, everybody kind of shares in the benefits. So there is stuff like optimistic execution. Optimistic execution is a process by which instead of validators, a validator creating the block, creates it, sending it to all of the peers, having everyone agree, and then producing the block, they instead do these two things in parallel. So as they are creating the block, I don't know how to represent parallelization, but they are at the same time sending it to people. And so right after this step, they can create their new block. It's a very bad idea, very bad representation, but this is what Say uses, for example. And they have something like 10,000 TPS and very short block
Just from
times.
that idea, basically.
Right, exactly.
Yeah.
And so that will go to every Cosmos SDK based chain soon, which is pretty awesome. So next you have the Cosmos SDK. Cosmos SDK is kind of this framework for building unique blockchains. It's built up of different modules.
Yep. And this is just general to Cosmos chains, not specific to Initia.
Correct.
Okay.
So modules in Cosmos SDK are basically little building blocks that change the way the state transition function works. So you would create a module for example, you could create one for the mempool. You could create, there is the bank module, which is probably the most used module. That's what manages balances for tokens, for NFTs, for each user account, similar to something like an ERC20 store. You have stuff like the governance module. It deals with tallying votes and making upgrades to the system. You could have something like a DEX module, a staking module.
And these all interact with each other.
Yeah. And so these are all, the idea is that as these modules, they can all build the chain up. They can all do different processes, but they are still isolated and separate, which means that you can create new ones that do whatever you want without affecting all the other modules. And so Cosmos SDK is kind of modular already, right?
But not modular enough.
Not modular enough, not yet. So then on top of the Cosmos SDK side, we put a VM. So we use the Move VM.
But not all Cosmos chains have.
Not all Cosmos chains have Move VM. So we created the first Move VM that works on top of the Cosmos SDK. Typically the one that is used is WASM VM, and the smart contracting language is COSM. WASM. There you go.
And for anyone not familiar with that, you can just think of it as a different EVM.
Yeah, a different VM, a different way to write smart contracts. It is pure Rust. It is a very nice, simple framework. It is the first smart contracting language that I learned personally. The initial layer 1 uses the Move VM, which is kind of this next generation smart contracting language. It unlocks basically what is object-oriented programming, which has typically not been a thing when writing smart contracts using Solidity or something like CosmWasm. So as we've played with it over time, we found that we loved it. And we think it's going to be one of the popular ones in the future. But ultimately, at Initia, we don't believe that VMs are something that we should be maximalists on. We are very VM agnostic. And that's why rollups on Initia can use any VM. And we support EVM, MoveVM, and WASM VM on top. But we'll get into that a bit later. And so the MoveVM implementation that we put on Cosmos SDK is very nice because it kind of binds together these two layers between the Cosmos SDK and the VM, which means that directly within Move, you can perform Cosmos SDK interactions like sending IBC transfers, IBC being that standard communication method of Cosmos, or doing things like interchain accounts, which is where you use IBC as like a messaging protocol to do an action on another Cosmos chain.
Yeah. So instead of writing everything as a Cosmos module, you can push some of that into
Exactly.
Move, basically.
And Move is a lot easier to work with.
Yeah.
Sweet. So also on the L1, we have a couple other things. So one is a layer 0 module. So all of these modules, by the way, are Cosmos SDK modules. So I guess we can remove this line. So a layer 0 module, what is this and why do we need it? Essentially, layer 0 is one of the biggest bridges and messaging protocols in the world. Right now, for interacting with Cosmos SDK-based chains, really there's only two bridge options. One is Axeler, which is another Cosmos chain. Right? So Axeler lives here. There's another chain. Ethereum and stuff send tokens into Axeler, and then Axeler sends them to the Cosmos chain through IBC. There's also stuff like Hyperlane, which is similar to Layer 0 in the sense that they get deployed on the smart contract side of the chain, and then they have their own message passing system. So
you could in theory put Hyperlane
in here. Yeah, you could in theory put Hyperlane here.
Yeah.
Yes. Okay. So the Layer 0 module acts as a Layer 0 endpoint, which allows you to communicate over Layer 0 system to any other Layer 0 enabled chain. The reason we built this as a Cosmos SDK module instead of as a smart contract on the Move side is because rollups on Initia, again, can be in any VM, right? That could be no VM at all, could all be built on the Cosmos side, EVM, MoveVM, or WASM VM. And because we eventually want all message passing and bridging between the initial Layer 1, a Layer 2, and any external chain to be done through Layer 0 system, we've just baked in a Cosmos SDK module into the chain, as well as other Layer 2s on Initia. So as soon as they get spun up, they already come with Layer 0 messaging by default. Mm-hmm. And it doesn't depend on what VM they use. Lastly, two other modules that we've built in here. One is the DEX module, and the other is enshrined liquidity. So these two play together nicely. The DEX module is basically just a DEX that we built directly into the chain. It allows you to do balancer-like pools, so weighted pools or stable swaps. Eventually, we'll add concentrated liquidity as well. And then we built this system called enshrined liquidity.
Yeah, do you want to get a little bit into
I'll
that?
come over here, yeah. So, enshrined liquidity.
So there's obviously a token which governs and is used for proof of stake on this chain, right?
Yep, that is the init token.
The init token.
So, typical Layer 1, they just have their token, right? Let's take the init token in this example. They stake this with a validator, right? So validators, I don't know why I drew the circle, but a bunch of validators, right? They're running the chain. They are producing blocks, right?
Yep.
You usually stake a single token to each of these validators. They use that to decide on like who gets to produce the block, and then they make it. This often is like a massive supply sink, right? If you look at proof of stake networks, they often have like 50% stake weights or like 30 or 40% of basically the entire supply that's just staked with these validators, and it's earning some yield, right? And the yield is due to inflation. So typically it's stake, you get paid in inflation, and the inflation is not coming from nowhere, right? You say you have 1 billion tokens in total, you might say, okay, 400 million tokens is going to be paid out as inflation over time.
Mm-hmm.
And this is your security budget, right? This is why a layer 1 sucks to run, because now you have something like 40% of your entire supply that is just being paid for your own native token to be staked with these validators, right? So we said, okay, how can we make this a bit more productive to the system? If we're already paying out so much in rewards to these validators, let's put productive assets to work and create something that's more beneficial for the system. And so we developed Enshrined Liquidity. This is basically a mechanism by which we stake init X LP tokens directly with our validators.
This is on the AMM.
So this is on the layer 1 and in the DEX module. So in the DEX, right, you could have something like init USDC, you could have init ETH.
So you can add to this liquidity pool, you get back a liquidity
You can
token.
Whitelist, any pairs in the DEX for Enshrined Liquidity, and you can set some reward weight to them. So let's say we're going to give 60% of our staking rewards to this one, and we're going to give 40% to this one. If we add a later one in the future that anyone can do through governance, they can add some reward weight to it. And now, just like you were saying, you add liquidity to the DEX, you get some LP token, so LPT2, LPT1. And then what you do with Enshrined Liquidity is you take these 2 tokens and you stake them with these validators.
Okay.
So instead of giving these rewards directly to just init stake, we're giving it to actual liquidity pairs.
Will you also give the option for direct init stake? Or
there will be a direct init stake, but it'll be part of this breakdown, right?
Okay.
So maybe if there's 5% for plain init, then this goes down to something like 35. The exact details are yet to be
we'll
decided, but
decided via governance.
Yeah. Basically we want productive assets that would be useful for the entire system.
Mm-hmm.
We build a massive hub of liquidity that's accessible for every layer 2 on top of Initia.
Mm-hmm.
And then you also unlock inter-layer 2 routing, which we'll get to later. Okay, time to get into some of the layer 2 structure.
Yeah, sounds
and
good.
Then at the end we can talk a little bit about Initia VIP, which is the last module on the layer 1. Okay, so now we will put this L1 is here. Initia. So the point of Initia is to let you build an app chain very easily, right? Some of the problems with building an app chain, like we said, was if you're using Ethereum, you might not have flexibility, you have no native interoperability, and it's fragmented. The problem with Cosmos is that you have to build a layer 1. So how do we kind of merge these two together? Well, we built a Cosmos SDK-based rollup framework. It's very similar to Optimism's Bedrock, which is their optimistic rollup framework for the OP stack, but it's built in the Cosmos SDK. I forgot a massive module that exists on the layer 1, which is called the OP host module. So the OP host module is basically our version of an L1 contract for a rollup that stores the state of every layer 2. That says like, okay, this layer 2, its sequencer is at this address.
Do you want to draw that?
Sure.
Kind of maybe do like a couple chains.
Okay, so we have layer 2, 1, right? Layer 2, 2. And then layer 2, 3. So they all have a similar setup as the layer 1 in the sense that they have Comet BFT here.
So they themselves have validator
You might
sets.
be wondering why they have this system. And it's so that, okay, typically layer 2s only have a single sequencer. But the reason why we put common BFT here is to allow decentralized sequencers to exist. So one of the biggest problems with layer 2s is, hey, you have a centralized sequencer. This one person is deciding all the transaction inclusion. Maybe they're going to do something suspicious. So we just take common BFT, we slap it on there, and now you could have anywhere from like 1 to 100 sequencers technically, but 100 would be very bad and slow, and there'd be no use of it being a layer 2.
Yeah.
Right? So typically we advise something like 1 to 5.
Okay.
And with this, you can still get around 10,000 TPS and still stick with 500 millisecond block times. The next thing that's on each of them is still the Cosmos SDK.
Which you can add whatever modules you want.
Yeah, whatever modules you want. However, we do rip out a couple of modules. So we take out some of the useless stuff like the staking module, because the staking module and the governance module on Cosmos are not very nice in the sense that if you have them, you basically need a token that's staked for anything to operate properly. And so we just rip them out and we say, if you're going to build a governance, build it on the smart contract layer for now.
So if you're going to use 5 validators, do you need those or can you do that?
You do not need those, no. We built a system within the OP child module, which is the pair of OP host, which allows you to do simple governance upgrades and come to consensus and do like basic things like that.
Okay, but it's not as
fleshed out, yes.
complicated.
Yeah. So the OP child module sits on every layer 2, and it basically allows you to do some of the simple stuff like upgrades. It also manages some simple state like what the off-chain bots are doing. So we also have OP bots. These bots are basically monitoring the state that is occurring here and also relaying state to the layer 1.
So if you write a new Cosmos SDK module, how do you declare that you have that state?
If you write a new Cosmos SDK module, what you do is you have a new binary of this chain. Basically, you then write a proposal with the OP child, and you say, okay, we're going to switch to this binary 2 at time 100. At time 100, all of the block production will stop by all of these validators, and then everyone will upgrade their binaries to the new one.
But I guess how do you declare what state you want to be stored here or to be checkpointed?
Oh, this state that's stored on OP host, I think is just basically some bundle of all the stuff that's happening here. And I don't think you have to specify what state that is being written gets put there.
Okay, and so what's in the final box?
Okay, and the final box is your VM of choice. So this could be the EVM, it could be the Move VM, and it could be WASM VM. And the last thing that's happening across these layer 2s is over here we have this thing called Celestia. Celestia is a data availability network. It's where you post blobs. So these OP bots that are running, that are relaying state between each other, are also posting blobs to Celestia.
Of the state.
Yes, of the state. And then on the layer 1, the validators, all these little guys, are running Celestia light nodes. That's my light bulb. And they are validating and ensuring that the state that is posted here actually got posted.
What happens if it doesn't get posted?
If it doesn't, then there's some like retry logic, but otherwise your layer 2 would have some problems and you need to go into a fraud-proof challenge. And basically the chain would stop if data is not being posted. And when that happens, there are now that you have an optimistic rollup, right? You need to basically, if there's fraud occurring. So fraud happens when there's an incorrect state transition. That means, okay, someone on the layer 2, one of these operators, did something malicious, right? They decided, I'm gonna take all your tokens, right? I'm just going to change it, even though that transaction didn't come in.
Mhm.
And so if someone that is a watcher or a challenger notices that, so some guy with a hat, this guy notices it, he says, bad, and then he does a fraud-proof challenge.
Mhm.
And what that means is basically this guy will report that the state transition shouldn't have happened that way. They will start doing a process with each other where basically we will call in the layer 1 validators. They will fetch a bunch of data from Celestia. They will then come to consensus amongst themselves on if either the challenger was right or the layer 2 operator was right. And then based on their decision, they will change who the sequencer is or who the challenger is. So basically, if this guy was wrong, they'll say, okay, you are no longer running this chain. We are going to fork this chain into a new chain using the last correct state.
Mm-hmm.
So L2, 1, 2. And we are going to assign a new sequencer address to here. But it is using the last state that was alive and correct.
So if someone builds a whole new Cosmos SDK module, how do they know to check that that was the right state transition? Do they run these binaries as well, or
Yes, these guys definitely run these binaries.
the checkers,
the challengers,
but the validators
100%.
don't?
The validators do not at the time, but it's a good thing all the data is being posted to Celestia, because then when they have to do a challenge, they can get the binary and rerun basically the
So
chain.
that's the process that will actually happen.
Yeah.
Okay.
Cool. Okay, so now that we have all these chains, right? We have all these rollups that exist. There's some benefits that Initia specifically provides that you don't get anywhere else. Aside from using these different VMs and having the customizability of Cosmos SDK, there's still so much that you need to do as a layer 2 to be operational and actually onboard users. So what are some of those things, right? Exactly. So bridging, oracles,
Mhm.
native USDC or stables, like wallet connection, so wallets. Yeah, those are the main ones. Sure, fiat on-ramps. Basically, all these things are very hard to get as a new chain unless you BD and you pay for a lot of this stuff. Or, for example, native stables, Circle is probably never going to launch CCTP access on your chain, right? And so having the benefit of Cosmos here and the layer 1 does a lot for this because it exists just to provide tools for these layer 2s. And so for bridging, for example, as we mentioned, there is the layer 0 module that will be live on all of these. So out of the box, they have instant bridging to basically any other layer 0 enabled chain.
Including each other.
And there's also IBC. So IBC is still the standard Cosmos-based communication method. It allows them to talk to all the other Cosmos chains. So Cosmos over IBC.
But the L2s could as well, not just the L1.
Yes.
Okay.
And then also, let's say ETH. And this is over layer 0.
Yep.
So a good distinction to make is that layer 0 can be direct to every one of these chains, but IBC can't. In the sense that technically you could create an IBC connection between a layer 2 and something like Osmosis, but you wouldn't want to do it because there's this big problem in IBC, which is pairwise dependencies. What do I mean by that? Well, essentially, if you bridged a token over IBC from chain A, okay, say we have these 3 chains, right? If I bridged a token from A to B, B to C over IBC, I would basically have token B, C. Sorry. Okay. I have this token from A that then came from B.
Mm-hmm.
Does that make sense?
Yeah. And what do you have once you go from A
Right.
to B? Just TA.
So if I go, yeah, that's good. T, A. Okay, nice. And then if I sent that same token from A to C directly over IBC, I would just have T, A.
But it's different than this TA.
But it's different from this TA.
This is
Because-
TAB, I guess.
Yeah, well, that's why it's TAB here once you're on C. So it depends on how you bring the token
And they're not
to
fungible.
a chain.
Is that
They're
the
not
issue?
fungible. Yeah. So I cannot convert from one to the other unless I backtracked. So essentially, if I had this token on B and I want to send to C, the canonical way would probably be sending it back to A and then to C. But in Cosmos, you basically had these liquidity hubs pop up like Osmosis where all the trading is done. And then now the question became, is the native token the one that is issued on a given chain? Or is it the one where sourced from Osmosis?
Mhm.
Like, how do we do all this tracking? It gets very problematic very quickly.
Whereas in the UI, they just show, oh, you have this token.
Yeah.
But under the hood, it's more complicated.
Well, not even. A lot of the UIs just show you this, where you can have like 10 versions of the same token on a given chain. This is why people complained about Cosmos's UX always being so bad.
So this is where LZ comes in.
So that is where LZ comes in the long term, right? It lets you do omni-chain fungible tokens. So I can burn from here and I can mint it on here. But in the meantime, because LZ is not live on all of our layer 2s yet, we can still use IBC. But how do we do it in an effective way? We basically use the layer 1 as an orchestrator of IBC. So if new tokens are coming in, they go to the initial layer 1 first, and then they go to a given layer 2.
So this is if an
Right.
L2 has its own token.
Yeah, if I could send, say, some random token, dog, from a different chain, from
From another
Osmosis.
Cosmos chain. Okay.
It comes to layer 1, and then it goes to this layer 2. Right, so now you have, what was the terminology we used again?
Dog underscore
Dog.
osmosis.
L1. Dog osmosis, you're right. And then L1.
But you're saying you don't do that. You just keep it here.
No, that is
Okay.
what we do.
Okay.
That is what we do. But if you're trying to then send from this L2 to this L2, instead of creating dog, osmosis, layer 1, layer 2,
Yeah.
right? We would instead route it down through this
Okay.
again. And so you would unwrap one step and you would get here as well, dog, osmosis, layer 1.
L2 2.
I feel like
Or
the
L1.
I feel like the notation was not helpful. Yeah.
Basically, it decreases the complexity
Yeah, exactly.
because
If you
everything
use,
is unraveled as it transfers between the chains.
Right.
Okay.
And so you use this layer 1 as like a way to ensure that you don't have this liquidity problem where everything gets new version of the wrapping because all transfers just go through the layer 1. And you have special hook mechanics on here.
Yeah.
So you can send things that will run contracts on here. Once the output is done, it'll send back the result. And so you can do cross-chain communication and interact with smart contracts on other chains just fine.
So normally with L2s on ETH, when you're sending assets back, it normally takes 7 days or something, right? How do you get around that here?
Yeah,
Because
okay.
obviously that's not good UX.
Good question. So we built this thing called Minute Swap. Okay, Minute Swap because we call the layer 2s on Initia. Initia stands for mini Initia, and minute because it's quick. But really, it's a lot quicker than a minute. It's just a few seconds. So this one gets a little funky. Okay, so say we have this layer 2. Say we have the layer 1. Right? We have the optimistic bridge.
Which is fast for sending from L1 to L2.
Fast for sending L1 to L2, but 7 days back down.
Yep.
And then we also have IBC. IBC is fast in both directions, but the problem is if there is something like a rollback or
you double spend.
Yeah, exactly. It's not as safe when it comes to what is happening on the L2 because you don't have this withdrawal period. If there's a single sequencer, they could rug all your money really quickly and then just IBC it all back.
Yep.
Right, which is why you don't really have instant bridges unless you have some other group verifying it. And so the OP bridge here and minute swap, how it works is if we send a token like init through the OP bridge, we get init on the layer 2. And then if we want to get back down to the native init, we would take 7 days, but we don't want to do that. So what happens if we bridged it through IBC, right? We would get init, layer 2, IBC. This obviously is not fungible with this.
Yeah.
Right. So what we did is basically we created this thing called minute swap, which creates a giant pool between the init on the layer 1, these versions of the IBC'd token, plus a bunch of the other ones from different layer 2s. So maybe you have like...
So every single L2 would go into this?
Every one that's whitelisted.
Whitelisted,
Yes.
okay.
So you have this massive pool that has like 50% the main init, then a bunch of percents as these other inits.
So what would happen if one of those goes
So
largely
there's
down
a
in
bunch
value?
of stuff around this, like rate limiting that only allows you to swap a certain amount of volume at a time over a given period,
Okay.
which protects about a lot of the rug from happening. If someone tried to basically take all the init and sell it, they wouldn't be able to. And that is like a tunable parameter. There is also basically a bunch of stuff that does auto rebalancing and arbitrage for this. So if there is a discrepancy between the price of these two, which should be near 1-to-1, you can basically do the reverse path, or you can do the path that takes 7 days, and you can do all these sorts of things to repeg it.
Presumably people will come in and do that trade.
Exactly.
Okay. And then will you also incentivize liquidity there?
Yes, so we can do the same thing as we do with Enshrine Liquidity because this is just an LP token that represents this entire pool.
Yeah.
And so we could say, okay, we're going to allocate a little bit of the staking rewards towards this. Okay, so a couple other things on our list here, right? We solve bridging for every L2 because they have IBC and layer 0.
And bridging, if you want to go L2 to another L2, you basically go down.
Correct.
Using this minute swap.
Yeah,
thing,
using minute
and
swap.
Then over.
That's right.
But minute swap has to exist for other tokens as well, not just init. Right?
It does have to exist for other tokens, for major
but those
tokens.
won't be incentivized.
Like USDC or ETH.
Or if there's a big L2 that has its own token, it could have its own version of that. Okay.
Well, if it's minted on the layer 2, it never went through the OP bridge anyways,
true.
so they could just IBC it. So you have IBC and you have layer 0 for bridging. The next is what about oracles? So oracles, how we solve that is the layer 1 actually runs this process called connect, skip connect. And basically what's happening is all of our validators, so all these little guys, they're fetching data. So they're going to CoinGecko, they're going to Binance, they're going to OKX, etc. They're fetching price data for this massive list of assets that we have, which can be very easily added to. So all of the validators, as they're coming to consensus on building the block, they're also coming to consensus on oracle prices. So they fetch from all these locations for all these assets, they come to consensus, and every block, they post these prices onto the layer 1.
That's kind of part of the block.
As part of the block. So anyone that's building on the layer 1 as a moved app could just fetch from the state and get all this price data very easily. So in the bots process that is working between a layer 2 and our layer 1 on Initia, we are also relaying all of these oracle prices. And storing them in the same system where it's stored on the Cosmos SDK side on the layer 1. So that means every layer 2 at the frequency of the layer 1 blocks will have fresh prices to be able to fetch. So that is something around every 2 seconds. they'll have this data for all of these assets to be able to get.
Mm-hmm.
And so that solves like basic oracles. If you're doing some sort of very high frequency like perpetuals trading, maybe you need faster oracles, and we can basically do this same process but with the sequencer set here. Or if you're doing something like lending, or maybe every 2 seconds is fine, you can just use this oracle data to begin with.
You can combine it with your own source too.
Yeah.
As a fallback.
Yeah. So the next piece is native stablecoins. Obviously, native stables are great because that means you have one-to-one minting and burning with Circle. You also have like a direct deposit to Circle accounts. So the next piece is native stables. Right? You want to have the ability to deposit and withdraw from Circle accounts. This is great for things like RWAs or having institutions. You want the ability to mint and burn this one-to-one to a different chain. Circle doesn't really give CCTP access directly to a new layer 2 that just got spun up. And so it is very hard to get this, right? Only the biggest blockchains or like Arbitrum and Optimism as rollups have this ability. And so in Cosmos, we have something unique. It's called Noble. Noble is essentially a Cosmos chain that all they do is asset issuance. So Circle deploys native USDC here. They have CCTP ability to mint and burn USDC on Noble chain. And then Noble has an IBC connection to our layer 1. So now what you can essentially do is you can CCTP from somewhere like Ethereum or Solana, one-to-one mint your USDC on Noble, IBC it to our layer 1 and up to your layer 2. And this can all happen in one transaction that you sign on Ethereum. It'll just do all the routing for you, and you can do the same thing in reverse. So you essentially have native USDC and CCTP access directly from your layer 2. And then the next one is wallets. One of the biggest burdens of using a new chain, especially one that's in a different VM, is you have to come down a new wallet. Typically on Cosmos, you have to use a Cosmos wallet. If you go use Solana, you have to use a Solana wallet. If you use Aptos and Sui, there's like unique wallets for both of them. But I am only a Rabby user, right? Like Rabby's the best wallet of all time, and I want to continue using it. So what we did is we added new types of signing curves for private key generation into the Cosmos SDK side of all of the layer 2s, which allows us to basically sign with EVM wallets, Solana wallets, Move-based wallets, or Cosmos wallets. So on any layer 2, despite what VM it's in, I can use the initial wallet widget, which will let me connect to Rabby, MetaMask, Kepler, Leap, like Phantom, Backpack, Petra, basically anything, as well as have built-in social logins. So you basically have that already done for you. No users are barred from entering your new chain. And then with this bridging system, we also built like a full front end that allows people to bridge directly into your rollup from any other chain, and it'll do all the routing that you need for you.
Yeah, you have to deal with that.
So direct from day one, as you launch your chain, you have bridging and a front end to get into it from anywhere. You have oracles, you have native stables, you have wallets for any wallet, and then there's also a fiat on-ramp in the similar way to how Noble is done. And then, of course, as a layer 2, you can use whatever VM you want. And you can do actually interesting things by changing the way transactions are ordered, how they're processed, using any or many different tokens for gas.
Yes, you want to detail a couple of those?
Very flexible.
Detail kind of a couple of interesting use cases.
So the Cosmos SDK, I'd say the most interesting use cases here are 1, custom VMs. This just unlocks like all types of developer ideas and thoughts, right? You're not limited to the scope of the way that the EVM is defined. And I wouldn't say a new VM like creates fundamentally new use cases, but it does allow you to think differently. And when you start to think differently, maybe you think about how to build an application differently, right? They're just tools that should be used depending on what your use case is. So now you have custom VMs that you can put on there. You also have transaction ordering, and I would say this is the second biggest one, because this means that you can, one, internalize MEV. That means by reordering the way that transactions are done based on auctions, you get to capture all of those fees.
So you can enshrine an auction, basically.
Yeah. Remember those mempool lanes I was talking to you about earlier? You can basically have those mempool lanes on every one of these rollups now. And using this system that lots of chains already use, you can capture all the MEV that is on your rollup. You can also change the way that transactions are ordered if there is something that you want to prioritize.
Yeah.
So like on Hyperliquid, we were seeing like maker taker bids are prioritized differently, or cancel bids are prioritized first.
As well, yeah.
Right, so just prioritization.
And other things that we...
And then other all the other stuff. Plus, like, you get to keep all your sequencer fees. We don't take anything on Initia. This is all just the spread that you have between how much people are paying you to make transactions and the data that's being posted to Celestia.
Okay.
And so that, typically, Celestia is very cheap, so you'd have a massive spread. Okay, the last thing that we'll get into, this is the economic stack. So this is Initia VIP.
Which stands for?
Vested Interest Program.
Vested Interest.
Basically, this is a mechanism by which we want to create buy-in from all of the layer 2s and build up the demand side for the init token. A lot of protocols, especially in Ethereum, they care very much so about the supply side of their token. How do we burn the supply, right? How do we reduce it to create demand effects? I think you're never going to be able to burn enough of a token to create those effects, unless you have some sort of Ponzi, which is plausible. But here, what we care about is building the demand. So how can we build new use cases for the init token across all the layer 2s and create the idea that, one, init is money. Similar to on Ethereum, how Ethereum is the gas token on all these layer 2s. It's the biggest in every DEX. It's the biggest in every lending market.
Do you expect L2s to use init as the gas token?
I think they will use whatever they want, and they should use their own native token.
Yeah.
But the thing about Cosmos SDK is you can have any or many tokens for gas.
You could pay in init
so
or
you could have init,
another,
USDC, a native token, some shitcoin, whatever you want. The second is benefits to layer 2s. So how can we use our token and our economics to bring more users to layer 2 to incentivize use cases that they care about, usage, and to keep users around over time, so retention. These are basically the two things that we care about, right? One, help the ecosystem win or help rollups on Initia win, because the only way that Initia succeeds is if rollups on Initia succeed. And two is cement init as being this canonical multi-chain currency. And so how does Initia VIP work? Well, basically, first you have this big bucket of tokens. So, okay, you have this big bucket of tokens. Wow. Art. Okay, init tokens. And now we split this into two different groups. One is called the balance pool. And this is, and then we have the weight pool. So let's say to start, there's a governance parameter that decides how much is allocated to each. Let's say the balance pool is 20% of these tokens, and the weight pool is 80%. Now what happens is every 2 weeks, some of these tokens get distributed to the layer 2s. How do they get distributed is based on these two pools. So first, the balance pool. It looks at all of the layer 2s, and it looks at how much balance of init they have on them. Okay. So if I have
basically
100 in it, and I have another 100, another 100. Each of these would get 1/3 of the balance pool's allocation for this week. And then the weight pool, if we still have 3 layer 2s, right, there is a gauge vote done by the layer 1 holders. So the layer 1 stakers, they come and they say, okay, we vote 30% of the rewards should go to this first layer 2, 40% to this other one, and then another 30% to this last one. And this can be decided just on voting because you like the project, or because maybe the layer 2 did a little bit of bribery, right? That is a very common thing that's used in DeFi for things like curve and convex. If you want allocation of emissions, like maybe you'll pay for some of them to get them steered your way, and maybe that'll help bootstrap your layer 2.
And that goes to the validator set of the L2 of the
So
rollup?
this now
Or
goes
where
to,
does this
okay,
init go?
so now we have basically, through these 2 mechanisms, we know how much init is being distributed to every given layer 2. Right? So you combine these 2 numbers with these.
It is obviously time average so that you can't
Yeah.
exploit it.
Yeah, you're good. You're safe. You have this stream of rewards. But how they're distributed to each layer 2 is decided by every layer 2. So the layer 2 themselves, so let's say layer 2A, they set a system of on-chain KPIs. So if they are a perpetuals platform, maybe they say we care about trading volume. If they're an NFT one, maybe they say we care about mints. If they are a lending market, maybe they say the dollar amount of borrows. Any combination of any of these, as long as it's on-chain and verifiable. Now what the layer 2 does is they submit a score to the layer 1 based on whatever metric they want, and they also say how they calculated it so that the layer 1 can make sure that that was correct calculated. And then these rewards, they get distributed directly to their users based on this metric. So it doesn't go to the layer 2 themselves, it goes to all the users based on their trading volume. Or it goes to the other layer 2 based on the number of mints you did, or the number of borrows. So it allows a layer 2 to directly incentivize what they actually care about incentivizing, and they can also take a small fee as like a commission, as like a validator does, to ensure that they are also getting rewarded for the economic activity coming to their layer 2. So now you're able to incentivize what you want by using the layer 1. And the balance pool obviously cares more about, do you have more init balance? Are you creating a new use case for it? If you have a big use case for the init token, you're going to get more of that. And this one is more about like how you're actually using, or like what are you actually building and do people care about it? And then there's one last mechanism here, which is that these rewards are distributed as escrowed init.
But actually, one side question: can the init on the chain be staked, or is that?
So the whitelist, we can basically whitelist different assets to track.
Okay,
on
so
a
there's
layer
like
two.
a liquid staking
So
version.
yeah, we could whitelist that, or you could say, okay, USDC balances now count for this as well. So they're all distributed to users as escrowed init. How do you unlock escrowed init? You have to maintain engagement. What does this mean? If I earned 1,000 escrowed inits based on my trading volume, right? The following epoch, so 2 weeks later, I have to maintain the amount of trading volume I did. If I maintained it, right, I'm gonna earn more escrowed inits this week. And I'm also gonna unlock some of my last week's escrowed init. If I did less than before, I will still unlock some of my previous epoch's escrowed init, but I will get less of it. And so basically what this does is it keeps users around over time if they want these rewards. I have to maintain usage, and it creates a flywheel because the more I use it, the more escrowed init I earn. The more I use it, the more init I will unlock. And the second way to unlock it is zap it into enshrined liquidity.
Okay.
So I could say...
and it's locked, I'm assuming.
Yeah, it's locked. So now this is beneficial for the system in two ways. Either I keep using a layer 2, right, which is great for the system overall, or I provide liquidity.
Mm-hmm.
And so these incentives or rewards are being distributed in a very efficient way.
Great. So is that VIP in a nutshell?
That's VIP in a nutshell. Still pretty confusing, but whoa.
Yeah, it makes sense.
There's some pretty cool protocols that are being built on top of VIP system to basically make it a lot easier, like convex-like things.
So any final closing thoughts about Initia?
Final closing thoughts. I know there's a lot of different working parts and pieces. I think the product UX that we've built is very nice and will simplify a lot of the experience.
Mm-hmm.
But I think fundamentally by owning the layer 1 system and the layer 2 system in tandem, we're allowed to make trade-offs that you would never have on a system like rollups built on Ethereum.
Mm-hmm.
Because there's so many different parties that are all competing that creates a big problem because you can't leverage network effects.
Mm-hmm.
The reason Initia can succeed and will be the only modular winner is because everyone uses the same tech stack, everyone uses the same data availability layer, everyone uses the same messaging protocol. And so together, because we can leverage the network effects, the entire system can grow a lot better with each other versus being parasitic. I often have this analogy that I'll leave you with, which is that Initia is like the Fed. I don't like to say that much because, Fed chain bad. But essentially, you can imagine Initia as like the US government and rollups on Initia as states. Everyone can do their own thing, but the system decides like how monetary policy works, how transportation or bridging works, how the Fed works, which is Initia VIP, and collectively everyone cares about growing the entire US. Versus rollups on Ethereum are a lot more like the EU. They only care about themselves, and the capital is Brussels. And we all know that Brussels sucks.